Welcome once again. In this series of lectures, we have been learning about powers and exponents, positive exponent, negative exponent, their different laws. We have already solved various types of exercises on them. We have also learned about usual form and standard form and how to convert from one form to another form. In today's class, we will answer short answer type questions or objective type questions based on the knowledge that we have already gathered in this series. And this is also important. So let's start the class. The first problem is given as minus 3 to the power minus 4. So here base is minus 3 and power is negative. It is the negative exponent minus 4. So we know this property that a to the power minus n is equal to 1 divided by a to the power n. It is in that format, a to the power minus n. So first we will express that as a to the power plus n. So it is minus 3 to the power 4. Now minus 3 to the power 4 means minus 3 has been multiplied 4 times. So minus 3, when it will be multiplied with another minus 3, it will, we know that will give us 9. And when minus 3 will be multiplied with another minus 3, so that will also give us 9. So we can write this way: 1 divided by minus 3 multiplied by minus 3, it will give us 9. And then minus 3 multiplied by minus 3, it will give us another 9. So in the denominator, it will be 9 multiplied by 9, so it will be 81. So final answer will be 1 by 81. Now the second question is minus 2 by 5 to the power minus 3. What will be its answer? Now again we know a to the power minus n will be equal to 1 divided by a to the power n. Now suppose this non-zero rational number, which is base here and which is expressed as a, this is expressed as a ratio of two integers c and d. So c divided by d to the power minus n, if it is, then we can write this way: 1 divided by c by d to the power n. Now this can be written as 1 divided by, it will be c to the power n and d to the power n. So when we are dividing 1 by this rational number, we will basically multiply by the multiplicative inverse of the second rational number which we have in the denominator. So finally it can be written as d divided by c to the power n. So the important property what we can see here, if it is suppose c by d to the power minus n, then that can be expressed as d divided by c to the power n. So this is one important property that we can frequently use to simplify our job. Now this type of problem where we have this rational number and that is expressed as a ratio of two integers. So if we use this property, this concept, then directly we can write that minus 2 by 5 to the power minus n. So it can be written as minus 5 divided by 2 to the power plus n, which is here the n value is 3. So it will be in the numerator minus 5 will be multiplied by itself 3 times, and in the denominator again 2 will be multiplied by itself again 3 times or thrice. So in the numerator it will be minus 5, when it will be multiplied by minus 5 it will be 25 plus 25, and again when plus 25 will be multiplied by another minus 5 it will be minus 125. So final answer will be minus 125 divided by, in the denominator it will be 8. Now let's move on to the next problem. Let's see what it has. The problem is about express 1 divided by 1 0 0 0 0 0. Here we have 5 zeros in the denominator in the form of negative exponent. Now if we want to express this as in the form of negative exponent, then what we have to do is, here it has 5 zeros. So first we will express this as an positive exponent of base 10. So if it is, then it will be 10 to the power 5. We know that when 10 is multiplied by 10, then it gives 100. So we have 2 zeros after 1, and this is expressed as 10 to the power 2. When 10 is multiplied by 10 thrice, so it gives 1000. 1000 means we have 3 zeros after 1, and it is expressed as 10 to the power 3. as here thrice we are multiplying 10 by itself. So when we have 5 zeros, that means we can say 10 is getting multiplied by itself 5 times. So it will be expressed as 10 to the power 5. 10 is base, 5 is positive exponent. And when it is in the form of 1 by a to the power n, this can be now written as 10 to the power minus n. So it will be this time 10 to the power minus 5. So it is expressed as in the form of negative exponent. So this will be our answer. Now the next question says that by what number should 5 to the power minus 1 be multiplied so that the product will be equal to minus 5 to the power minus 1. So let's assume that that number is x. Okay. Now that number is x and that will be multiplied with this, the second number, which is 5 to the power minus 1. And when we will multiply these two, the result of product or the result of multiplication will be minus 5 to the power minus 1. Fine. Now we have to find the value of x. What is that number? So x can be written as minus 5 to the power minus 1 divided by 5 to the power minus 1. So both the factors, both the values, the numerator and denominator, they have negative exponent. So first we will express the value that we have in the numerator as in the form of positive exponent. So it will be 1 divided by minus 5 to the power 1. As it was minus 5 to the power minus 1, so it is 1 divided by minus 5 to the power 1. A to the power minus n will be equal to 1 divided by a to the power n. Now we have in the denominator 5 to the power minus 1. So this will be expressed as 1 divided by 5 to the power plus 1. Now here we are multiplying two rational numbers. So first number we will write as it is minus 5 to the power 1, and then we will multiply by the multiplicative inverse of the second number. So it will be 5 to the power 1 by 1. Here 1 divided by minus 5 to the power 1, and when as base we have any non-zero rational number, and when the power is 1, we know the result is that rational number only. So it will be 1 divided by minus 5 only, and again 5 to the power 1 means it will be 5 only and divided by 1. So 5 and 5 will cancel each other. Basically this is minus 5, so it will be the factor that will remain in the denominator will be minus 1. So final answer will be 1 divided by minus 1, that means minus 1 only. So this number 5 to the power minus 1 should be multiplied by minus 1 to get this value, minus 5 to the power minus 1. Now let's see what is waiting for us next. Express this number in standard form. The number which is given here it is a decimal number, but this is the usual form of decimal number. Now we have to convert this, or we have to express this into standard form. Now in standard form, we know we have before decimal point we have one non-zero integer or digit. So since here the non-zero digits are 1, 7, 3, so when we will express in standard form, it will be basically 1.73. Keeping this in mind, we have to adjust the other zeros and we have to accordingly multiply some factor which will have maybe positive or negative. Let's see what it will be. So in the standard form it will be 1.73. Now since we are moving towards right, so we will be multiplying by 10 to the power minus some negative value. So 10 to the power some negative exponent. And this minus n, this n represents the number of places by which the decimal point is moved by. So here if we want to move this decimal point after, if we want to move this after 1, then we are moving this decimal point by 1, 2, 3, 4, 5, 6 places. So here after 1.73 we will be multiplying by 10 to the power minus 6. Then this 1.73, when we will be multiplied by 10 to the power minus 6, this will give us this value only. But this is the usual form and this is the standard form. Now we have again in the next question we have another number which looks as an integer, and that has to be again expressed in standard form. Now since this is this number 589 and after that we have 4 zeros, this looks integer, but this can be considered as again a decimal. but the decimal point will be at the end, and after decimal point there will be 0. So since after decimal point the zeros that we have, they don't they are not significant, they don't have any meaning, so that's why we don't write the decimal point and the zeros after that. So it looks like an integer value, but we have to consider that the decimal point is at the end, and before decimal point in this number we have 1 2 3 4 5 6 7 digit, and since we want to represent in standard form, so 5 8 9, these are the three non-zero digits, so it will be the first digit is 5, so it will be 5.89, and then we have to do the adjustment. So 5.89, so here the decimal point initially was at the end, and if we move this decimal point after 5, then how many places we are moving by? We are moving by 1 2 3 4 5 6 places. So it will, this time we are moving towards left, so it will be 10 to the power plus n, and here n again signifies that how many places we are moving the decimal point by. So here it will be, the value of n will be 6. So initially this decimal point was here, and we are moving this decimal point by 1 2 3 4 5 6, so it will be 10 to the power 6. We will be multiplying this value 5.89, which is the standard form, by this exponent, positive exponent, and then when we will multiply this 2, we will be getting this value only, or this value only. Now we will move on to the next question. The next question is, it is given in the form of an equation. So 5 to the power 2x, when this is divided by some other value which is given in the form of negative exponent 5 to the power minus 3, the result is 5 to the power plus 5. So what we will do is, here we can see on both the sides of this equation, the base, all the bases are same. So what we can do is, first we will express this negative exponent in the form of positive exponent. So it will be 5 to the power 2x, then divided by, it is a to the power minus n, so it will be 1 divided by a to the power plus n, and then that will be equal to 5 to the power 5. So here it will be 5 to the power 2x. Now since we are dividing, so we will be now multiplying by the multiplicative inverse of this number, so it will be 5 to the power 3 only, and then that will be equal to 5 to the power 5. Now if we use this law of positive integral exponent, then we know that a to the power m, when it is multiplied by a to the power n, where the base is same but the exponents are different, then it gives us the value, then it is equal to a to the power m plus n. The exponents are added. So here if we follow that law, then it will be base is same, so it will be 5 to the power 2x plus 3, and then on the other side we have 5 to the power 5. Since base are same, so we can cancel their base, and the exponents will have this equation, 2x plus 3 will be equal to 5. Now this is a simple equation, so 2x will be equal to 2, 5 minus 3 will be equal to 2, so x will be equal to 1. So this is the way how we can solve this type of equation involving positive and negative exponents of some base. Now the next question is 1 divided by 1731 to the power 0. This is a rational number which is expressed as a ratio of two integers, but whatever is the non-zero rational number it is, if we take the power, if the exponent is 0, then we know that value will be always 1. So we don't have to think what we have as base. It is a non-zero rational number, the exponent is 0, so value will be, with closed eyes we can write the value will be 1. Now let's see what is the next question. Next question is 2 by 3 to the power minus 5. Fine. Then that is getting multiplied by 3 to the power 7 to the power minus 5. Since here one interesting point is, here the both the rational number, they have, both the bases have negative exponents, but both the exponents are same. So what we can do is, we can write this way, that 2 divided by 3 into 3 divided by 7, then to the power minus 5, because we know this property that when a b to the power m, when these two are bases and these two bases are multiplied, and then we take any positive exponent of that, then that can be expressed as a to the power m multiplied by b to the power m. And just we are using this property, this law, in reverse order. This is given in this format, and we are going from right to left. So it will be a multiplied by b, so 2 divided by 3 into 3 divided by 7, and then power is minus 5. So 3 will cancel each other, so it will be 2 divided by 7 to the power minus 5. And we have already seen that if it is 2 divided by 7 to the power a to the power, or a by b to the power minus n, then that will be written as, if it is suppose a divided by b to the power minus n, then that will be equal to b divided by a to the power plus n. So the final answer will be 7 divided by 2 to the power 5. Then 7, if it is multiplied by itself 5 times, then the value will be 16807, and when 2 is multiplied by itself 5 times, then that value is 32. So this is the answer. Now the next question, what it says, it has the form similar to the previous question, but instead of multiplication we are dividing here. And again we know that we have this law that when we divide two different bases, and with that, basically this is a rational number, so with that result of division, if we take a positive exponent, then that can be expressed as a to the power n divided by b to the power n, the positive exponent of their individual bases and ratio of them. So if the problem is about 3 by 4 to the power minus 2 divided by 1 by 4 to the power minus 2, provided the exponent has to be same, whether it is positive exponent or negative exponent value has to be same, bases can be different. So if it is, and it matches with this format, so again we will move from right to left. So a to the power n is this is a, this is n value minus 2, and divided by b value is 1 by 4, and again n value is same, which is minus 2 again. So we will be writing this way: 3 divided by 4, 3 by 4 divided by 1 by 4, then whole to the power minus 2. So internally we will perform this division first. So 3 divided by 4, and then we will multiply by the multiplicative inverse of 1 by 4, this rational number. So it will be 4 only, and then whole to the power minus 2, and that will be equal to 4 will cancel each other as they are in the numerator and denominator. So it will be 3 to the power minus 2. So again it is in the form a to the power minus n. So it will be 1 divided by a to the power n. 3 square means 9. So it will be 1 divided by 9. So this class was about objective type of questions that is very important in exam and in competitive exam also. So I hope this class was interesting and meaningful to you. So with this I end today's class. Thank you.